So in this video, I'm going to go through a couple of examples of finding the nth term for quadratic sequences. So for the first one, we have the first four terms, 1, 2, 3 and 4, are 0, 7, 16 and 27. So the first thing that I would do is I would work out the difference between each term. So 0 to 7, I need to add 7. To get from 7 to 16, I need to add 9. And to get from 16 to 27, I need to add 11. But to get from 7 to 9, I need to add 2. And from 9 to 11, I need to add 2. So because you get this constant layer, that is telling you that it is a quadratic, because it's a constant layer at the second row. Now, because that's 2, you half that number, and that's the coefficient of n squared in the nth term formula. So half of that is 1, so we're going to have a 1n squared. So because we know we're going to have a 1n squared, I'm going to figure out what n squared is as a sequence. So that'd be 1 squared, 2 squared, 3 squared, 4 squared. And then we subtract those two away. So we get rid of the n squared bit. Okay. So 0 take away 1 is minus 1, 7 take away 4 is 3, 16 take away 9 is 7, and 27 take away 16 is 11. So now we should have a linear sequence, an arithmetic sequence. So we are adding on 4 there, adding on 4 there, adding on 4 there. So we know that the 4 goes in front of the n. And how do we get from 4 back to minus 1? Well, I need to subtract 5 in order to do that. So that's the linear part, the arithmetic part of the overall nth term. But don't forget, we had n squared in there as well. So it's n squared plus 4n take away 5. That's the nth term for number 1. Right, for number 2, we have that the first, second, third and fourth terms are 7, 7, 11 and 19. So first of all, let's investigate the differences. So here we're just adding 0, then we're adding 4, then we're adding 8. So onto the differences, there's a difference of 4 and then a difference of 4. So because you get the constant layer at the second row, that's telling me it's a quadratic. We halve this number to get 2, so that means it's a 2n squared that we're dealing with. So 2n squared, if I substitute in 1 into that, I'm going to get 2. 2 into that, I'm going to get 8. 3 into that, 2 lots of 9 is 18. 2 lots of 16 is 32. So then I subtract that away. 7 take away 2 is 5. 7 take away 8 is minus 1. 11 take away 18 is minus 7. And then 19 take away 32 will be minus 13. So investigating this should now be an arithmetic sequence. To get from 5 to minus 1, I need to subtract 6, then subtract 6 again, then subtract 6 again. So because I'm getting minus 6's there, that's minus 6 that goes in front of the n. Then how do you get from minus 6 to 5? I need to add on 11. And don't forget, we had a 2n squared as well. So 2n squared take away 6n plus 11 is the nth term for my second example.